Hello everyone, welcome to the e-learning program of CsCl College Nasik. I am Dr. M.K.Deore from the Department of the Physics, CsCl College Nasik. Dear students, now in this lecture we are going to see about the crystal structures of the different materials such as the sodium chloride, cesium chloride and diamond. Students, in the previous lecture we have seen about the three basic type of the structures such as the simple cubic type of the structure, body centered cubic type of the structure and the face centered cubic type of the structure. Now in the body centered type of the cubic structure, we have seen that there are the 8 atoms are located at the 8 corner of the unit cell and the one atom is located at the center, body center of the unit cell. And in case of that the FCC type of the structure, similarly here that the 8 atoms are located at the 8 corners of the unit cell and the 6 atoms are located at the center of the 6 faces of the unit cell. Students, you should also know about the contribution of the every atoms in the unit cell. Now here in case of that the BCC type of the structure, the contribution of the corner atom in this unit cell is only the 1/8 part of these atoms, and the contribution of the atom which is located at the body center is whole. But now in case of that the FCC type of the structure, the contribution of the atoms located at the center of the face of the unit cell, its contribution in this unit cell is only the half of that atoms. So when you are going to study about the structure of the different materials, then you should know about these three basic type of the structures and the contribution of the every atom located at the corner, at the body center, at the face center and at the edges of the unit cell. While studying the structures of these different material, we will see about these different points such as the type of the structure of the different materials. The second is the type of the oids present in the structure. Third one is the coordination number and fourth one is the number of the atoms present in the unit cell. Now here we are going to study about the first type of the material is the sodium chloride. The sodium chloride is also known as the rock salt and we know that it is an ionic compound with the chemical formula NaCl. Now if we see here that in the NaCl molecule, so the ratio of the sodium and the chlorine ions is 1:1. So the chlorine having the negatively charged ions and the sodium having the positively charged ions. Now in the chemistry point of the view, we say the sodium and the chlorine ions, but for the physics point of the view, we are considering the sodium atom and the chlorine atoms here. Now here, the radius of these ions take a very important role during the formation of the structure of that material. So the position of these ions will be depends upon the size of that ion. Now see here, the radius of the Na plus ion is 1.16 angstrom unit and the radius of the chlorine ion is 1.67 angstrom unit. So we can say that the anions are greater than the cations. Therefore here the chlorine atoms having larger than that of the sodium atoms, so the chlorine atoms form the FCC type of the packing and are present at the 8 corners of this unit cell, and the 6 atoms are present at the 6 faces of the unit cell. While the sodium atoms is a smaller size as compared to the chlorine atoms, so the sodium atoms are present in the octahedral ovoids and they are present at the center of the 12 edges and the one atom is at the body center of the unit cell. The unit cell having the 12 edges, so the sodium atoms is present at the center of the every edge of this unit cell. Hence we can say that the NaCl has the face-centered cubic type of that the structure. It is also known as the cubic closed packing type of that the structure, that is the CcP. In the second point we are going to see about the total number of the NaCl units and the total number of the atoms present in the unit cell. Now here we know that the chlorine atoms are present at each corner of the unit cell as well as the 6 faces of the unit cell. Now here in the unit cell there are the 8 corners and the 6 faces. Therefore, the total number of the atoms equal to be the contribution from the 8 corners of the unit cell of the Cl atoms and the contribution from the 6 faces of the unit cell of the Cl atoms. So here the contribution of the corner atom is 1/8. Therefore, the 1/8 multiplied by the 8 plus 1/2 multiplied by the 6, you will get the 1 plus 3, so equal to be the 4. Hence, we can say that the total number of the chlorine atoms present in this unit cell equal to be the 4. Similarly, in case of that the Na atoms are present at the center of the edge of the unit cell and the one atom is at the body center of this unit cell. So here this is the center of the unit cell. So its contribution is only the 1/4. Therefore, the contribution of the Na atoms from the edge center plus the contribution of the Na atoms from the body center, so equal to be the 1/4 multiplied by the 12 plus 1 multiplied by the 1 is equal to 3 plus 1, so equal to be the 4 Na atoms. Hence we can say that there are the total Na atoms present in this unit cell equal to be the 4. Thus, this unit cell consists of the 4 NaCl unit. Therefore, we can say that the 4 Na atoms and the 4 Cl atoms gives the 4 NaCl units present in the unit cell. Now the number of the atoms present in the NaCl structure, the density of the atoms is comparatively large, as compared to the simple cubic and the BCC type of the structure. So the FCC structure having the packing fraction equal to be the 0.74. Now the third point here we are going to see about the coordination number. Now we have already defined the coordination number. So now we are going to see here the coordination number of the Na plus atom with respect to the Cl and the Cl atoms with respect to the Na atoms. Now here the every Na atoms and the Cl atoms, it gets surrounded by 6 its neighboring atoms. That means the Na atom gets surrounded the 6 chlorine atoms. So we can say that the Na atoms get coordinate with the 6 neighboring chlorine atoms. Therefore we can say that the coordination number of the Na plus atom with respect to the chlorine is 6. Similarly, here the chlorine atom is also get surrounded by the 6 Na atoms. So the Cl atom, it get coordinate with the 6 neighboring Na plus atoms. Therefore we can say that the coordination number of the Cl atom with respect to the Na atom is also the 6 here. Thus both Na atoms and the Cl atom having the coordination number is 6. So the structure, we can say that the structure having the 6 as to 6 coordination. Now in the third point, we can see the position of the type of that ovoids present in this unit cell. Now if we take the radius ratio of the cations to the anions, then in this NaCl type of the structure, the radius ratio equal to be the 0.69. Now then if the radius ratio is greater than the 0.41, then there will be an octahedral arrangement of the anions. So in this type of the structure, we can see that the cations will be able to accommodate the 6 anions. Now here this is the first, you should know about that O2 you mean by the octahedral type of the ovoid. Now in this octahedral, now here this is the one, it may be the anions or the cations, and if we consider here this is the cation, now then the 6 anions are get surrounded around these cations, and if we connect all these anions with each other, now then there will be the formation of the octahedron, and such a type of the ovoids present in this unit cell is known as the octahedron. So therefore now we can see here, if we connect here, suppose here the sodium atoms, suppose now here this is the sodium atoms is located in such a way that now there are the 6 chlorine atoms around it. If we consider here this is the sodium atoms, now then 1, 2, 3, 4, 5 and the 6 atoms are located or get surrounded around these sodium atoms. Therefore we can say that the sodium atoms occupy the octahedral site. Means here and in the octahedral sites and in this structure, NaCl structure, now there are the 4 octahedral sites of the sodium atoms. Now then how that the sodium atoms having the 4 octahedral site, that can be, we can see from this structure. Now there is the one body center atoms and there are the 12 atoms are located at the center of the edge of this unit cell. So here from this you will get the 4 sites. So in this unit cell, the sodium atoms will be present in the octahedral, will form the octahedral at the 4 sites. Similarly, in case of that, we can see, if we consider here, this is the chlorine atoms. Now then again there are the 6 atoms are surrounded around these chlorine atoms. Therefore the chlorine atoms will also occupy the octahedral site. So similarly in this NaCl structure, the chlorine atoms will also occupy the 4 octahedral sites. So remember about that, what do you mean by the octahedral site, and how the sodium atoms and the chlorine atoms will occupy the octahedral site in this NaCl structure, and how many octahedral sites will be the possible in case of that the Na atoms and the Cl atoms. Now the last point is that the coordination numbers here. Now the fractional coordinates of the fractional coordinate of the Cl and the Na atoms. Now if we consider here in this unit cell, if we consider here, this is the x-axis, here this is the y-axis, and this is the z-axis. So we can determine the fractional coordinates of the every atoms located at the center of this unit cell, located at the edge centered, located at the face centered, and the body center. Now if we suppose if we consider here, this is the first chlorine atoms here. Now if we consider it is at the origin, now then its coordinates are along the x-axis, y-axis, and the z-axis 0, 0. In case of these, the second atoms, which is in this xy plane and which is at the center of the lower face of this unit cell. Therefore if we go toward the x-axis, half of this edge, so its x coordinate is 1/2, its y coordinate is 1/2, but its z coordinate is 0. Therefore the coordinates of these chlorine atoms are 1/2, 1/2, and the 0. Now then in case of this, the third chlorine atoms, now it is in the yz plane, so here its x coordinate is 0. Therefore the coordinate, the xyz coordinate of this third chlorine atom is 0, 1/2, 1/2. Similarly in case of that, the fourth, these chlorine atoms, now it is located in the x and the z plane, so its y coordinate is 0. Therefore the xy z coordinates of this chlorine atom are the 1/2, 0, and 1. Similarly we can find here the coordinates of the Na atoms also here. Now then here, this is the body centered atoms, which is at the half, which is located at the center of this unit cell. That means from this origin, if we find its coordinates, now then it is located at half of the edge of this unit cell. So here its x, y, and the z coordinates are 1/2, 1/2, and 1/2. Now in case of that, the second atom, Na plus atoms, now see here, it is also along this, its coordinate, it is along the, it is on the y z axis. Therefore here it's, and it is at the center of this edge of the unit cell, so its z coordinate is 1/2 and the x y coordinates are the 0. So here its coordinates are, x y z coordinates are the 0, 0, 1/2. In this way, for the atom sodium atom third and for the sodium atom 4, So in this way we can find the fractional coordinates of the chlorine and the Na atoms in this unit cell. So dear students, in case of that the NaCl type of that the structure, for the examination point of the view, you have to know about how the structure get formed, which type of the structure is this, that is the FCC type of that the structure. Second one is the how many total number of the sodium and the chlorine atoms present in the unit cell, and also the how many NaCl units are present in that the unit cell. Also that you should know about the coordination number of the Na plus ion with respect to the Cl atoms and the Cl atoms with respect to the Na plus atoms. Next one is that you should also know about that which type of that ovoids present in this unit cell and how to locate, how to determine the coordinates, fractional coordinates of the chlorine and the Na atoms. Thank you. Here we are going to see the structure of cesium chloride. Cesium chloride is the inorganic compound with the formula CsCl. Now initially we have seen that the radius of the atom and the radius ratio of the atoms decides the position of the atoms in the unit cell and the formation of the type of the structure of the unit cell. In case of the cesium chloride, the atomic radius of the Cs atom is 1.65 angstrom unit and the atomic radius of the Cl atom is 1.67 angstrom unit. It shows that the size of the chlorine atom is greater than the size of the cesium atom. Hence, the chlorine atom form the simple cubic type of the packing and the chlorine atoms are present at the 8 corners of the unit cell, while the cesium atoms are present at the body center of the unit cell. In case of the radius ratio, if we take the radius ratio of these two atoms, now then it is observed equal to be the 0.98. From the observations, it shows that if the radius ratio is greater than 0.74, then the structure will be the BCC. Thus, the formation of the cesium chloride structure is also a BCC type. Thus, in a CsCl, the arrangement of the atom is simply a body-centered cubic structure in which the 8 Cl atoms are present at the 8 corner of the unit cell and the 1 Cs atom is present at the body center of the unit cell. Now, here we are going to see about the total number of the CsCl units and the total number of the atoms present in the unit cell. Now see here in this figure, now there are the 8 Cl atoms are present at the 8 corners of the unit cell. Therefore, the contribution of the Cl atoms from these 8 corners of the unit cell equal to be the 1/8 multiplied by 8, it is equal to the 1, because the contribution of the every corner atom is only the 1/8. Therefore, the total number of the Cl atoms in this unit cell equal to be the only 1. Similarly, in case of that the Cs atoms, there is only one Cs atom is present at the body center of the unit cell. Therefore, its contribution in this unit cell equal to the 1. Therefore, we can say that the unit cell contain only one Cs and only one Cl atoms. Thus, a unit cell contain only one molecule of the CsCl. Thus, the space lattice is simply a BCC with one molecule of the CsCl present in the unit cell. Therefore, you have to remember, in case of that the CsCl structure, there is only one molecule of the CsCl is present in the one unit cell, and the one Cs and the one Cl atom are present in the one unit cell. Now here we can determine the coordination number of the Cs atoms and also the Cl atoms also. Now here in the first figure we can see here the Cs atom it gets surrounded by the 8 Cl atoms which are at the corners of the unit cell. Therefore, we can say that the coordination number of the Cs atom with respect to the Cl atom is 8. Similarly, now if we connect the 8 unit cell, now then we can see here this chlorine atom, it gets surrounded by the 8 body centered atoms from the 8 unit cell. Now here, now these are the 4 body centered atoms from the front side of the unit cell and the 4 body centered atoms from the back side of the unit cell. Thus, the coordination number of the Cl atom with respect to the Cs atom is 8. Thus, we can say that the structure having the 8:8 coordination. Now here we can locate the position of the Cs atoms and the Cl atoms. Now in this unit cell, if we consider here this is the x-axis, this is the y-axis, and this is the z-axis, then if we consider the Cl atom which is at the origin, now then its coordinates are 0, 0, 0, and this Cs atom which is at the body center of this unit cell and which is present at half of the edge of this unit cell. Therefore, its x, y and z coordinates are 1/2, 1/2, 1/2. Thank you.